Welcome to This Explainer. Today we're tackling a massive, incredibly expensive headache that, honestly, almost everyone has dealt with at some point. Erratic power surges, completely destroying your expensive home appliances. Picture this, you just plugged in a brand new, top-of-the-line OLED TV. You're so excited. Then, out of absolutely nowhere, a sudden voltage spike hits your house's electrical grid. And just like that, the internal circuitry is totally fried. It is a homeowner's absolute worst nightmare. But here's the good news. It's entirely preventable if you just have the right hardware sitting between your wall outlet and your tech. To make sure you never lose another appliance to bad power, here's our roadmap for today. We're going to cover the power fluctuation problem, take a peek inside a voltage stabilizer, compare the different types out there, and finally help you figure out exactly how to choose the right capacity for your home. All right, part 1, the power fluctuation problem. Let's define the battlefield. A voltage stabilizer is essentially your home's intelligent gatekeeper. It takes a wild, totally unpredictable input voltage from the mains, and data shows this can swing dangerously low, down to 150 volts, or surge to a hardware-frying 280 volts. But the stabilizer automatically smooths all that chaos out. What you get on the other side is a perfectly safe, stable 220 volts, which is the exact, reliable range your load was designed to handle safely. So, how exactly does it pull off that magic trick? Let's move to section 2, inside a voltage stabilizer. At the very heart of this system, we have a basic transformer. This uses a primary coil and a secondary coil, both wound around the exact same iron core, to step the AC voltage up or down. Think of it kind of like adjusting a nozzle to control the water pressure in your garden hose. By changing the ratio of the turns of wire between the primary and secondary coils, the transformer mechanically alters the voltage to the exact level you need. Now, this basic concept builds into what's called an autotransformer, which is what you'll actually find inside these devices. Instead of two completely separate coils, the main transformer here has just a single, continuous winding that does double duty as both the primary and the secondary. The truly brilliant part here is the tap changing mechanism. We've got automated switches that change the taps along this single continuous coil to instantly select a completely different turns ratio, automatically adjusting the voltage up or down based on whatever the house's power grid is doing at that very second. And the actual muscles making those crucial tap changes, those are the relays. Now, a relay is really just an electrically operated switch. But instead of you walking over and flipping a switch by hand, these use tiny electromagnets. When it's energized, an iron core becomes a magnet and automatically pulls down an armature. That physical movement is what switches the circuits on or off, instantly changing the tap on the autotransformer. So the most crucial point to take away is this rapid three-step dance that happens in literally the blink of an eye. First, electronic control circuits detect a sudden voltage drop or spike. Second, the correct electromagnetic relay is immediately energized. And third, the tap changes to adjust the turns ratio and stabilize the output. It's this continuous, non-stop cycle that keeps your delicate appliances perfectly safe. Okay, moving right along to section 3, types of voltage stabilizers. Let's compare the actual tech on the market. There are 3 main heavyweights in the industry. First up is the relay stabilizer, which is low cost and simple, using stepwise adjustment. Then we have the servo stabilizer. This one actually utilizes little motors for moderate, continuous adjustment and can handle much higher capacities. And finally, the static stabilizer. This is fully electronic, boasting incredibly high precision. We're talking staying within plus or minus 1% accuracy, and it handles dynamic changes instantaneously, with absolutely zero mechanical parts. If we contrast the two extremes here, relay units are highly affordable and really simple to maintain, but they do have a somewhat shorter service life because of mechanical wear and tear, and you're definitely going to hear an audible clicking noise as those relays snap open and closed. On the flip side, static units are totally silent and incredibly fast, but they rely on really complex solid-state microchips like IGBTs or thyristors, which puts them at a major premium price point with a lot higher maintenance complexity. But hey, here's what you really need to take away from all this. Despite the mechanical wear and slightly lower voltage accuracy, which usually hovers around plus or minus 8 to 10%, the Relay Stabilizer is unequivocally the absolute champion for the everyday home. It gives you the absolute best cost-to-protection ratio for your basic gear, hands down. If you just need to keep a fridge or an AC unit safe, this is 100% your go-to device. So, that brings us to Section 4, choosing the right capacity and how to properly size your stabilizer. When you're looking at output capacity for standard household loads, your refrigerators, air conditioners, and TVs, you generally only need a relay stabilizer with a capacity rating of under 10 kVA. kVA stands for kilovolt amperes, by the way, which is basically just a measure of the total power load the unit can handle. Under 10 kVA is the absolute sweet spot for home protection, offering a really economical, air-cooled shield against daily grid fluctuations, all without over-engineering your living room. In stark contrast, if you were, say, outfitting a massive industrial factory with heavy machinery, or maybe a massive data center that requires incredibly stable power, you'd need to step way up. We're talking servo or static stabilizers capable of pushing a massive 5,000 kVA or more. Those crazy environments demand continuous adjustment and handle a scale of electricity that a simple home relay would just never ever survive. So we finally arrive at the ultimate question. After seeing exactly how these ingenious little devices act as an automatic shield, using transformers, electromagnets, and continuous tap switching to fight off electrical chaos, you gotta ask yourself, are your expensive appliances actually safe today? Or are you just rolling the dice every single time you plug something into the wall? Don't wait for the next surge to find out the hard way. Thank you so much for joining me for this explainer, and as always, stay curious.